Hi, I'm here to talk about Arista AlgoMatch, which is an innovation for advanced network policy enforcement that is targeted at the needs of next-generation cloud networking. We all know that today's highly dynamic cloud networks require flexible and programmable policy control mechanisms. However, traditional policy engines in switches and routers frequently struggle to address the challenges of scale, flexibility, and flow visibility at the same time. Cloud networks, we know, need something better. Arista AlgoMatch is an Arista innovation that provides precisely this: a more flexible and more scalable solution to provide access control, policy-based networking, and telemetry that's needed for today's cloud networks. Compared to existing solutions, AlgoMatch, at its heart, relies on a more efficient packet matching algorithm that is better suited to take advantage of the flexibility and programmability that's available in today's advanced merchant silicon. Some of the advantages of AlgoMatch include better scale of filtering, including support for multiple actions on a packet or flow, better handling of IPv6 enabled networks that puts policy control for IPv6 on an equal footing with IPv4. Now, this is very important as cloud networks are increasingly looking to migrate their infrastructure to IPv6, and in that environment, providing v4 and v6 policy control at parity is an absolute requirement. Lastly, it provides advanced accounting, telemetry, and security auditing that's needed by the cloud. So under the hood, AlgoMatch relies on general-purpose memory in place of more costly and purpose-built TCAMs, or ternary content addressable memories. TCAMs, as you may know, have been powering packet classification algorithms across multiple generations of networking products. But TCAMs are not, in fact, optimal for today's cloud networks for multiple reasons. First, cloud network operators are building v4 and v6 infrastructure and expect to deliver one common service for v4 and v6 with equal levels of control, as I said. However, traditional TCAM-based solutions have struggled to provide this equality because the large size of v6 addresses compared to v4 addresses makes them mismatched to the TCAM technology. Secondly, TCAMs typically have limited flexibility to meet the application-specific requirements and provide more advanced packet matching. In that vein, TCAMs are good for matching one key against a fixed set of rigid patterns, allowing any bit of the key to be ignored in any of the patterns. And this sounds powerful, but the underlying technology required to do this is expensive. And in their implementation, TCAMs necessarily are forced to make sacrifices in terms of scale and power. A ternary CAM performs a lot of work, but it is fundamentally a brute force technology. Internally, a TCAM is a large memory with entries that correspond to every policy rule, and it can be used to find the best policy to apply to each packet. But the way the TCAM operates is to light up every single memory cell on every single packet. Moreover, the memory cells provide individual masking on every bit. And this necessitates a different type of memory cell that is larger than normal memories. And if one field, such as, say, the TTL, or time to live, is used in even one policy rule, all the other rules in that ternary CAM still examine the unused field and then ignore the result of matching it. And this is fundamentally an inefficient and power-hungry approach to searching. The fundamental challenge that they're up against is that they provide flexibility where it's not actually needed, and yet still lack the flexibility and programmability where it is needed to provide the policy control needs of the cloud. At the heart of Arista AlgoMatch is indeed a better software and hardware architecture for programming policy rules that delivers improved power efficiency and uses less resources for the same or greater scale. Through our improved algorithms, we achieve up to 4 times the density of traditional TCAMs, and at the same time provide improved visibility with more counters for long-term analysis. Compared to the brute force approach of ternary CAMs, AlgoMatch delivers better scale at lower power with more flexibility. AlgoMatch is able to achieve this by combining advanced logic with SRAM memories that have been highly optimized by the chip vendors for density and lookup speed. As illustrated here, the packet search in AlgoMatch lights up only a fraction of the total memory, using dramatically lower power for the search than a TCAM would, while simultaneously using smaller memory cells that allow us to pack more rules into the same area. At the same time, the logic allows us to provide flexible policies that optimize for customer requirements such as IPv6 scale. AlgoMatch addresses the cloud requirements of network policy, supporting v4 and v6 as equals, and providing better flexibility with deterministic performance. I am excited to say that we have implementations of AlgoMatch coming soon as an EOS feature on the Arista 7000 series of 10, 40, and 100 gig fixed and modular switches. I hope you'll try it out. Thanks for your time.